Okay, today in class we discussed vectors, and we will determine how to find the magnitude and the direction of the vectors, and then we'll perform translations with vectors. Okay, a vector, and to write that just a little bit bigger, it has a half arrow over it, and that's what it's denoted as. That's how we write it. This is a quantity that has a directed distance that has both a magnitude and a direction. So on a coordinate plane, you can get a vector. It has an initial point and an ending point. It stops right there. So that's how we know it has a distance. And then the direction, because of the arrow here, it tells us that what direction it is going. Standard position, if the initial point of the vector is at the origin, then we say that the vector is in standard position. So for example, the initial point would be there at the origin, and it could be going in any direction. Okay. Component form, this is sometimes called the ordered pair representation, but this is always your change in x and your change in y. Or it's always our x2, we call that our terminal point minus the initial point, and that's for both coordinates. And then we use these brackets here to represent a vector. So your magnitude is just the length of a vector. It's denoted by that. So if you do the absolute value of the vector, we're looking for the magnitude, the length. Sometimes we call it the distance, and it's found by taking this formula here, which you should recognize as the distance formula. Amplitude, we use theta to represent direction. It's sometimes called amplitude or sometimes the angle of direction. To find the direction, you're going to measure the angle that the vector forms with the positive x-axis or any other horizontal line. And then we'll use trig ratios to find the angle, and that's important. We're going to use our trig ratios to find the angle. And because we're looking for an angle, we're going to be using an inverse. So here we are in example 1. The first thing I'm going to ask you to do is find the component form, and then we'll graph it from there. So to find the component form, remember that we do x2 minus x1. So 2 minus a negative 2 will give you 4. And then we take y2, 5 minus y1, 1 gives us 4. And then we're going to graph this by going over 4, up 4 to get to that point, and then we have just put this in standard position. And from here, we're going to find a couple things. I would suggest that you draw the triangle and then label what we know. We know that this distance here is 4 and this distance is 4. So to find the magnitude, there's several ways we can do that. We can either use the Pythagorean theorem, which is pretty fast on our triangle here, or you could use the distance formula. So I'll probably do the 4 squared plus 4 squared. And so 4 squared plus 4 squared is 16 plus 16 is 32. So that's the square root of 32, which will then become 4 root 2. Or you can give me the decimal value for 4 root 2 as well. For theta, and we talked about if these sides are the same, then we do know that this formula here to get that side, it's hypotenuse equals leg root 2. So that's why that becomes 4 root 2. And if these sides are exactly the same, we also know that we have an isosceles right, which means that our base angles are the same. So that angle is 45. And I guess I should show you the angle that we're talking about is this angle here, and it's 45. But the way we would actually find it if we didn't recognize that we have a 45, 45, 90 triangle is that we would take these two sides that we know and we would say what trig function uses opposite of the angle and adjacent, and that's tangent. So because we're looking for the angle, we take the inverse of tangent of 4 over 4, which is just 1. And then when you type that in your calculator, you get 45 degrees. So I have lots of examples. I wanted to show you what each of these would look like in each quadrant. So for this one here, you're still going to write the component form of the vector by taking x2 minus x1. So negative 3 minus negative 5 gives us 2. And then y2 minus y1, 6 minus 10 is negative 4. So we graph over 2, down 4, and draw our vector from the origin. And we can see that we are in quadrant 4. We draw our right triangle here, and we're going to be looking for the length of our vector, and we're also going to be looking for the angle, the direction of our vector. So to find the length or the magnitude, we can use the lengths on the triangle. We have 2 this way and 4 this way, so 2 squared plus 4 squared. 2 squared is 4 and 4 squared is 16, so that gives us the square root of 20, which reduces to 2 root 5. Or you can give me the decimal form of that number as well. Then to find the angle, we're going to take theta and say, because we're looking for an angle, we're going to use the inverse. And then you go back to the idea of SOHCAHTOA that we learned in our last section. And we see that we have opposite, it's our opposite to the angle, and we have an adjacent to the angle. So there's only one function that uses opposite and adjacent, and that's tangent. So we're going to take the inverse of tangent because we're looking for the angle of the opposite. In this case it's 4 over the adjacent 2. So when you type that in your calculator, we get 63.43 degrees, but the only thing you have to take into consideration is that we have taken our vector and we start at the positive x-axis and talk about the direction. So it has gone almost a full circle, so to find out what it has traveled, we have to take this angle that we just found and subtract it from 360. So when we subtract those, we get 296.57. And that is the angle. So I know on our paper we said that if it's in quadrant 4, I think they wrote this down, then you're going to take 360 minus the angle that you find to find the true direction. So example 1, we're still following the idea that we want to find the component form. So negative 3 minus 1 is negative 4, and 7 minus 4 is 3. So we're back 4 and up 3. And there's our vector. And then after that you want to draw your triangle to help us find the length of that, or the distance, or the magnitude of our vectors. And this is a 4 and this is a 3, and hopefully you recognize that that's a 3, 4, 5. So the distance of our vector, or the length or the magnitude, is 5. Then to find the angle here, we're going to use our original values 3 and 4. And because they're opposite and adjacent to that angle, we're going to use tangent. So the inverse of tangent, because we're looking for an angle, of the opposite, 3 over the adjacent, 4. So we type that in our calculators and we get 36.87 degrees. Now, like the last one, our first one, if you notice, we were in angle, or quadrant 1. If you're in quadrant 1, then you don't have to do anything to that angle. But if you are in any other quadrant, you've got to consider that it starts from our positive x-axis and travels a direction. So it's traveled that direction. To find that, it's not quite 180 degrees, or half a circle. So we're going to take 180 and subtract the 36.87. And that gives us 143.13, and that is the direction of our vector. So on our papers we wrote that if it was in quadrant 2, our rule is that we would take 180 minus theta. Okay, so again we're going to do the component form by taking x2 minus x1, so negative 2 minus 8, negative 10. And y2 minus y1, so negative 2 minus 3 to give us negative 5. And this puts us in quadrant 3. I'm going to go by 2s so that I can stay on my graph. So there is our vector. You're going to draw your triangle and label our distance. Across this top I guess the horizontal distance is 10, the vertical distance is 5. And then we're going to be looking for theta, but before we do that, we're going to actually look for the length of our vector. To do that, we'll take our 5 squared plus 10 squared, and then take the square root of that. So that will either give you 5 root 5, because you get 100 plus 25 is 125, or the square root of 125 is 11.18. So I'll accept either of those answers. From there you have to find the angle, and then we have our adjacent and our opposite. The only function that uses both adjacent and opposite is tangent, so we're going to take the inverse of tangent of the opposite, 5, over the adjacent, 10. So when we type that in our calculators, we get 26.57. Now, again, we talk about the direction. It's traveling from 0 all the way past 180. So to get past 180, we're going to add 180 plus the 26.57 to find the actual direction, which is 206.57 degrees. Okay, a resultant vector occurs when you have 2 or more vectors and you add them together. Sometimes they call it stacking end to end. So if you had a vector here and a vector here and you added them together, you would move this to the end of this vector to stack it end to end. And then your resulting vector would start here from the beginning and end here. And that would be what is known as the resultant vector. So vectors can be combined by performing composition of translations by adding the vectors. Now we know that composition is more than one transformation, so we're going to do more than one translation and show you how it's actually a vector. Okay, so here we're going to start by graphing ABC. And then it asks you to graph the vertices under the translation of 5, -1. What that does is it moves every point forward 5 and down 1. And that gives us our new triangle there. And then it wants it under the translation of n. And so that takes our red one and it moves it back 2 and down 3. Now, what I wanted to show you, if we had actually just gone from each vertex to the blue and kind of eliminated the idea of the red, what would that take to get there? And we can count on our graph. It says it would have to go forward 1, 2 from the purple, 1, 2, 3, forward 3 and down 1, 2, 3, 4. Or the idea that we have a resultant vector from these two, meaning we can add those vectors together. So we get 5 plus -2 is 3, and -1 plus -3 is -4. So if you wanted to take the original purple image and actually add the 2 vectors to get this vector here, the resultant vector, and then apply it, then you would eliminate that middle step of graphing the red triangle. I don't care if you want to graph those individually or graph it as one using the resultant vector. Either way, you'll get to the right answer. Okay, example 3, it wants you to write the component form. We have, or I should say, the resultant vector. So I have 2 vectors. I'm going to go ahead and get the resultant vector. That means you're going to add the vectors together. So 0 plus 4 is 4, and -9 plus 6 is -3. And then we're going to graph this vector by going forward 4 and down 3. And then we have to find the magnitude and direction. So I'm going to draw a triangle and label the sides to find the length of this vector, or the magnitude. And we can see that it's a 3, 4, 5. If not, you could do 3 squared plus 4 squared and then take the square root of that to come up with 5. And then we want to find theta. Theta is our direction, so we have an opposite and adjacent, so that means we're using tangent. because we're finding an angle, we're going to use the inverse of tangent. Opposite over adjacent. So 3 over 4. So that will give us an angle of 36.87 degrees. Now remember that this direction has to start from the positive x-axis and move this direction, so it's actually not 36.87. We have to subtract that from 360. It's not quite a circle, and that will give us 323.13 degrees. On example 4, it says, suppose a pilot begins a flight along the path due north, flying at 250 miles per hour. So I think I'm going to have to go by 50s on my graph. So to get 250 due north, 50, 100, 150, 250 will put us right there. So we have a vector that's going 250 due north. We have a wind that is blowing due east, not each, at 20 miles per hour. Now we can put that down at the bottom. I'm going to go by tens. Or we can actually move it to the top so that you guys can see the resultant vector a little easier. So our resultant vector, when we add those, should look like that. And we're going to be looking for our angle for the direction, and the velocity will be the magnitude of the vector. So to find the magnitude of the vector, we can take our triangle 250 squared plus, that should be 20 squared, and then take the square root of it. And that will give us approximately 250.80 miles per hour. And then we need to find the angle. What will that wind do to our plane? To find it, you're going to take, we have an opposite and adjacent to our angle, so we're going to use the inverse of tangent. If you notice, we've used the inverse of tangent all day on this assignment. So the inverse of tangent, you'll take 20 over 250, or 2 over 25, and you get an angle of 4.57 degrees. And that is going northeast. So if you'll label your directions on these, that would be great. Well, that should do it for your assignment. Good luck on 10.5 vectors.